This is a production of Cornell University.
Oh, yeah, 3 people.
Great.
And if you're too lazy to copy all this down, all the info about the meeting tomorrow should be on our website, so ucsu.cornell.edu. Thanks, Bailey.
Hey, no problem. Right. Sure. Of course, that's not going to behave, as always.
If you have any questions, my email address is on there too.
Have you told them much about what ACSU is?
Well,
I'm just going to have to fire up the computer scene as well.
what the ACSU is?
Yep.
Well, as I said, it's an organization just run completely by students. The way it works, there's a lot of events we traditionally do every single semester. We have general meetings where professors come. We organize info sessions for companies, which in turn gives us the money to get the food food for all the events and things we do. At the end of the semester, we usually have some sort of big social event. We played laser tag last semester. I think we have a happy hour coming up in a couple of weeks. We once had a bunch of bands, Bailey being one of them, that came and played in the basement of Blue Ops, which was pretty awesome. We just do, and we're always open to new events, so we're just doing whatever we think we can that's in the best interest for CS class, Anyway, if you want to find out more on what we actually have planned and what to look out for, just come to our general meeting tomorrow.
Cheers. Thanks a bunch.
Thank you.
Okay, so while I'm waiting for the computer to warm up, first of all, any questions? Yes, sir. Beautifully timed question. So the question was, is there any way to write a method which returns two different values? And the answer is, of course, no and yes. The real way that works is, no, there isn't, because that's the official answer. And then the way that there's a yes answer is, think of, birthday times and such like, when somebody wraps up a nice little present for you, and you open the present, and there are all these yummy things inside. And that's the way to do it. In other words, create a class which has various entities inside it. Then you can return some instantiation of that particular class, together with all the packages and things that you wanted to send along with it. And so that's the solution. Yes, providing you wrap it up appropriately. Next question, yes?
Are we supposed to implement any tries and catches for the second part of the homework?
So the question was, are you supposed to implement tries and catches for this current homework? And the answer is no, but if you do, that's nice. The next homework certainly will give you plenty of opportunity to do that, and I would recommend you do. This time, no. But think about it. How sophisticated do I want the security? So the question, in some sense, think of the homework exercise. The first homework exercise is using some statistical decryption on some file, which basically tells you, gosh, encryption isn't that hard to crack, because you didn't know anything about the system that was was setting it up, except it was a simple, relatively straightforward one. And then the second aspect of the homework was building a simulation of a kind of banking environment. Oh, good. And the question to that is, obviously you want some sort of security. So I'm going to draw money out of this bank account and pay it to somebody else who's going to put it into their bank account. So it would be nice to at least check that this person is authorized, maybe asking for a password or some secret identifier. Do I want to have sort of retinal scans built in and you apply sensors to people? Probably not. I mean, if you've got spare time to do that, then I wonder about your general use of time. And I know that at university we're supposed not to have a life, but I want you to pretend that you could at least have a virtual one to go with the Java virtual machine. There's all sorts of other stuff we could talk about with the security and so forth, but think at least at the level of, I'm passing information from here to there. I want money to go from this person to that person. do I really need to send in the clear all the banking details of this person across to that person? And the answer is no. Indeed, do I need to send any banking details across from this person to that person? Again, the answer is no. All I need to do is to send something which identifies the transaction and authorizes me in some way. Now, if you think of smart cards, the idea there is you have a little computer sitting on the card which can do very basic calculations. So that instead of sending information across the net, I basically insert this mini computer into the smart card reader, and the computer over at the bank asks me a question, or rather asks the card a question, which the card can then do a local computation on and say, oh, given what you asked me, I think my answer will be such and such. Somebody spotting that transmission in the clear could say, I know a question and an answer. But of course, it doesn't know what question is going to be asked next time, nor why it was that this card responded with that particular answer. The question might be, take your birthday and add today's time to it and return the number. That sort of thing is what will make it then much harder. So I don't actually need to send very much information. Certainly things should be private using the Java stuff. But if you had the spare time, which on the Tuesday with homework being due on the Wednesday, probably isn't your top priority list. I believe how many of you are taking other classes? Right. So you probably have other priorities at this particular point. But think about that, because it's not unheard of for me to ask a question later on in the course which might draw on what you've done already. So thinking about it a little bit and think, how might I improve on this, might not be wasted effort. Next question, yes.
Professor, I have two rather detailed questions. The first is, so when you pay the salary, do you need to consider about the salary pay date?
So two detailed questions. The first one, given that you're paying a salary, does one need to consider the salary pay date? First of all, if you didn't do salaries, that's fine. Salaries weren't mentioned as being there, though it's a natural thing to do. And then if you are going to have salaries, do you want to have a salary pay date? Well, how are you accounting for time in your program? If you have some way of accounting for time within your program, whether it's a discrete thing or something running on accelerated time or real time, then you can consider there a pay date if you wish. Or you might simply build it saying, I'm going to put a pay date into the program and have in my mind, later on I'll implement something which uses it. That would probably be my recommendation at this point. Second.
If I want to do the salary, I need to do the pay date.
No, you could simply pay all the salary at the end of the year or the beginning of the year and hope they don't resign halfway through. And the second question?
And also, I'm trying to simplify. Can I just make an assumption that each person only have one savings account and one credit card?
So in terms of simplifying, can you assume they only have one savings account and one credit card? Sure. It's a sensible place to start. And for this present homework, it's probably also a sensible place to end. Next time will be more sophisticated. 1 and 2, and then I'll go on with the lecture material.
Suppose you have variable declared at the beginning of an object, and the variable draws from another file. Does it only update that when it first initiates the object, or does it update that when it reacts?
So I have a variable in an object, and it's being given its values by reading some file, and does that value get updated at any other time, essentially? And the answer is, presumably that variable is there. You have some method which assigns values to it by reading the file. Oh, it reads it from another class, and that other class read it from the file. No. Let's talk after class about that. And there's a question here.
Just a question on the authentication. Like when the way like we've written, like designed ours, is that there's a separate bank account object is created, right? So and every person, like it's superclasses, like a lot of like employers and other things like our employees and stuff like that. So they all have an account associated with them. Like every person we're assuming has a bank account.
Mm-hmm.
So when you go to make a withdrawal or something, is it redundant to call the accounts its own ID that's already associated with that person to verify that this person is actually accessing their own account.
So the question is about what level of authentication do you need to make sure that people are drawing from their correct account. There will be many different ways you will have taken on to do this. And so what I'm actually going to do with that question is, rather than go into great detail on it and then have 9/10 of the class say, oh no, I didn't do it that way, when I left it wide open, I'll deal with that more privately. We'll talk about some fairly clever ways of dealing with authentication and connect that with better ways of doing encryption a bit later on in the course when we have some more techniques available. It's entirely the right question. There's, as I said, there are multiplicities of answers at this relatively early stage in the course. I don't want to make everyone think I didn't do it the right way when it could have been. Because if you go to all the banks, you'll find they're doing things in slightly different ways themselves. So there are many right answers at whatever level of sophistication you want to employ. Okay. So you'll recall that last time we did a first exercise running a pair of threads. It was a relatively straightforward problem. We had a class which created a thread. There are several ways we can go about doing that. The particular approach we took here was to extend the thread class and have this. Essentially, the only thing we need to do is to define what the run method is. That is what's going to happen when we actually start the thread. And if you look at that particular run method, what it does is it takes whatever word I feed into the system, coupled with whatever time delay I put, and prints out that word, goes to sleep, prints out the word, goes to sleep, and so forth. And the method that called upon that took the word ping, printed it out every 333 milliseconds. There's a caveat to that. And took the word pong and printed out that every second. Same caveat will apply to that. And the net effect of this utterly thrilling program was it in that one? Was this exciting output. Now I should give you some, obviously it's just going to keep going ping pong on and on until the computer runs out of memory, which will probably take this computer about 10 minutes, because all this stuff is just being written up onto the console and it's just spewing the stuff out pretty quickly. There are some issues. First of all, don't assume that sleep is an accurate way for getting precise timing. It doesn't work for you. It doesn't work for the computer. What sleep is, it says, okay, I'm not going to do anything for a bit. In this case, the bit might be 333 milliseconds. After which it says, anything, any reason I should do anything? Okay, I'll do something. So you can't assume it will happen exactly every 333 milliseconds. So don't do it for mission critical stuff. Building some cardiac pacemaker using thread sleep might be unfortunate. Secondly, they don't both start at exactly the same time. There's the main thread, which then spawns a thread doing the ping printing, and then spawns a thread doing the pong printing. So probably the initial thing, next time I run it, might have 2 pings before a pong initially, and then it may go on. Who knows? And to be honest, who cares? What we've got here are 2 threads running independently. Now, to save the computer crashing to a halt, yeah, make a run method which does both things. So when that thread starts, it starts both exercises. Still, don't assume perfect accuracy. If you look at the API, you'll find you can even throw in a thing which will give you more accuracy down to nanoseconds. That's to make you feel good. There are so many other processes going on in that particular computer, just running the operating system and all the rest of it. Unless you've got good ways of making sure you've got tight control on it, forget it. So there's the summary of what we were doing there. There are other ways we can do stuff. For example, you know that we can only inherit from one class. And so here I have some method extending the thread class. What if I wanted to extend the bank account class, but I also wanted to have a run method? I can only have one parent. Therefore, I can either have the thread or the bank account. That's sad. So the solution we have is you can extend as many classes as you like, but we'll just reword it. We'll have something called implements, which smells kind of like inheritance, but isn't quite. My usual comment is, at certain points I'll tell you things that are maybe sort of light, low alpha value white lies, and I'll fill in more details a bit later. And essentially this is the same exercise. There's an interface called Runnable, which, guess what, expects you to run something. And so you have to give a definition for the run method, and it's basically exactly the same as I did last time. So public class run ping pong, just to give it a different name, implements Runnable. Again, we have string word, the delay time. I have a constructor. I didn't need to do it in quite the same way last time, but here, last time I used super on the constructor from thread. Here, we're giving the constructor there. No real difference there. Slight change over here for the main stuff. I let you know that little and bigger, to give them fun names, are runnable type things. Little will be a new run ping pong. Remember, new says get the computer to create something. What's it going to create? It's going to create a runnable-like object. And in this particular case, it's going to create a run ping pong type object. Initializing with the word ping, again with the word pong. I then create a new thread, some anonymous thread. I could have given it a name and said thread sausage equals new thread little start. Thread sausage equals new thread based on that other one, and built them on that particular exercise, but I'm taking the Runnable approach. Questions? It's an alternative way which allows you to do the same kind of exercise. There's a lot to say about interfaces, and I shall. But I want to say something a little bit more about the issues with threads. And the kind of picture I have out there is the kind of thing that can go wrong. Suppose I have a bank account. Of course, I talk about this because the homework was talking about bank accounts. By the way, don't feel you now have to suddenly change your homework for tomorrow based on what I'm telling you today. This is for later. So I have a bank account using my trusty laser pointer. Well, suppose there's some thread that reads the value of my balance, which happened to be 93. Euros, dollars, pounds. And then someone generously put $2,000 in, so it's going to bump up the value of my balance. And then I want to know what my balance is, and I see that it's 2,093. Entirely good arithmetic. Suppose there's another thread, which is going to read the value of my balance, 93, deposit $500, 593, and read the value of it. Operating independently, life is fine, nothing is wrong. But we have one thread moving in an independent way, this one moving in its independent way. And the question is, what might happen if thread A reads the value, thread B reads its value, and I don't care what thread A does after that, but at some point thread A says, okay, I'm going to write that value, because thread B already knows what the value was because it's read it. And it says, okay, the balance is 93. Oh, I'm going to take my time on this. Okay, we'll add 500 to it. Yeah. That makes it 593. Okay, I'll write that value to the person's balance. And the net effect is the person has a balance of 593 and the deposit of 2,000 evaporated. Oh dear. Well, it went from the donor's account. Who knows, it might have even got written into the bank's assets. But you didn't get it. Each thread's information on its own was okay. But the two together had this awkward issue. It's as if the two threads were racing against each other. Indeed, we actually call it a race condition to make it seem sophisticated and hard, when really it's just a case of, oops. So there are ways that we can solve that. Oh, by the way, oops, plus, plus. You might think that, oh, that's just a quick statement. Technically, what's happening there is you take some value, you read the value, you add one to it, you write the value. So that's just as susceptible to danger as that example up there. If you're reading things, you've got two threads and they're just reading stuff, you're probably okay. If you've got two threads reading and writing, you're probably not okay. If you've got one thread reading and making judgments, maybe if statements, and another one reading and writing, again, you may not be okay. It's the writing that makes it dangerous. Consequently, there's an approach we can take called synchronized, which you might think synchronizes things. No, it doesn't. It's the usual exercise of take a nifty word and use it in such a way that it only means something special to the people who understand what it means. What it really means is the first one to get there is the winner. Name, sir? Jordan. So Jordan is the holder of the bank accounts. And who shall I pick on? Matt. Okay, it's a race. I win because I'm cheating and you're being courteous. So I got access to Jordan immediately. And you can try doing whatever you like. You can try spending money, depositing money. It doesn't matter. You can't do a thing until I release control. I hereby dub thee Sir Jordan. Right, fine. So the net access, now of course Matt has access to do whatever he likes. So what synchronized does is it doesn't determine which thread will get there first. It merely says that any resources that are being controlled by that which I've declared to be synchronized is locked by the first thread to get access to it until it's finished. That then deals with this race condition issue, because the first thread got access to the balance. The second thread wanted access but just had to wait on the sidelines until thread A was finished. Thread A adds the $2,000. Thread A says, okay, I'm done. Thread B goes and accesses it. It does the read. 2,093 adds 500, 2,593, and life is decent. So putting synchronized on it solves that problem. Of course, with any solution, there are dangers. Otherwise, what would be the fun in life? So, danger number one. Suppose, as might be reasonably expected, Matt and Gary and a whole bunch of people up here are pretty efficient in life. Indeed, let's assume, as is probably the case, that everyone over on this side of the room is really efficient. Indeed, the only person not efficient in this room is me. And you all want to do a quick transaction on Jordan. And of course, you're being so courteous and nice and all the rest of it, and I go and nab hold of Jordan, so courtesy of the synchronized exercise, I've got complete control, and I'm going to go through this long, lugubrious exercise, and the rest of you are just sitting there waiting, watching the clock, wondering, is he ever going to get out of this mold of... No. He's just going to be here for the next... How long's the lecture? I guess another 2 hours. You get the gist. If I have some slow process going on and it happens to get first access to the assets, all the rest of you are sitting there waiting. You could almost imagine that that might be some sort of system for, I don't know, choosing tickets for something, or courses, or whatever else it might be you're after. You've got to make sure, and that's where the cleverness comes in, that there's some reasonable apportioning of resources. We'll talk about how to do that stuff a bit later, but for the time being, be aware that that's danger number one. Danger number two, a nice little example which comes out of the Java books I've been mentioning to you from the Sun site, is here I have thread A, thread B, and we're going to assume that there's some class G, which is a nice friendly class, and it likes to hug things. And it also has a method for hug back. And, well, we're getting close to Valentine's Day, so, it seems reasonable. And so then we have the exercise of, we'll assume the hug method calls the hug back method. This is all sitting in there. So, thread A, we have a particular object of type G called X, and X decides to hug Y. Very kind of it. And we'll assume that everything has been synchronized because we just learned about synchronization, and we know that that's possibly the universal panacea. And it is, because it guarantees that no harm will come in a very careful sense. So X hugs Y. So therefore acquires a lock on Y. But why, on all the resources that are going on over here. So it has a lock on Y. Y decides, in thread B, it calls on Y and it says, hey, Y, why didn't you go and hug X? And Y says, okay, fine, I'll go and hug X. So Y is going to hug X and therefore has a lock on X and all its resources. So then the X hug Y, remember I said the hug method was going to have a hug back because it was nice in reciprocating things? So Y says, oh, I got hugged, I'll hug back. But unfortunately, there's a lock. A now wants a lock on X, but Y, this thread over here, already has a lock on X, so therefore the hug back can't happen until this hug method on thread B has finished. That's okay. Unfortunately, the hug method calls the hug back method. So now the hug back method is wanting to operate, but so now B wants a lock on Y. But it's being blocked by A. So the hug, first hug was fine. The hug called by the other, thread B was fine. The hug back in thread A is waiting for the hug in thread B to finish. And then the hug back in B is waiting for the hug, but that can't even. So no harm can occur because nothing will occur. They're just sitting there waiting. Nobody's doing anything. Nobody will. So the computer runs out of power. It's called a deadlock. Sad. So, yeah, synchronization is nice. It protects things. And in all cases of protection, you have a balancing act. How much will I protect and how much will I be able to use? You could probably apply that in many areas outside computer science, though I'm only talking about computer science. Questions? And if you're interested, you can even use the word synchronize on whatever things you care to put in those parentheses, which will synchronize some block of code, because clearly step one is try not to synchronize more than you actually need to, so you don't hold resources for too long. And some comments over there which you can read and play with. And that, I think, should be the end of that set of notes. And let's see if that other thing is readable. So far, so good. Meow. Good. So batch 3 of notes, which I'll put up right after class. This is, of course, incomplete because I'm in the process of doing the notes, but I will enhance on it. We introduced this thing called the Runnable interface. Interfaces in general are nice things. They're very useful. They're useful because to you, you're working probably now in pairs on projects. You're probably working in larger groups. That's fine. The question is, how do you actually program in larger groups in a way which is reasonably effective? Well, think threads. What you really want to do is to have some main thread that gets things started and then spawns these other things working kind of in parallel. So you may as well do the same for yourselves working on programming projects. Get the thing designed and then find some effective way to split it up so half the people can be working on doing one bit and half the people can be working on doing something else. And that's exactly what interfaces are for. They are, if you like, a kind of spec sheet that lays out, this is what I plan to do. So essentially, I can plan the outline of the classes I want. And once that planning process is done, then half the people can be implementing those methods and making the classes actually happen. And the other half can say, well, they're going to do the right thing, so I'll build the stuff that uses those classes so that when they're built, we got the homework done or the project done, whatever the exercise is, from homeworks to major corporate exercises, doesn't matter. So this is an effective way of divvying up the work. It's got other benefits as well. Essentially, it's just a contract stating this is what I plan to do. So let's imagine something fairly straightforward. Building a queue, which probably to most of you is called a line. You know, there's a line here. Somehow reminds me of the time when I was in Paris a bunch of years ago, and I learned that what the real meaning of a line for food in, when you wanted to get bread. There may be a line, but the person who has greater need and has the sharper elbows would get in, grab the bread and get out of there, which made sense because I was usually flapping around in standard schoolboy French and making a mess of it. And the people who have more to do in life, well, if he wants to practice his bad French, we'll just get the stuff. So what is a queue in essence? And what do I care about? And you might have a whole bunch of things you'd really like to do with a queue. But in essence, it's something which you join at the back and you leave at the front. And hopefully as the person leaves at the front, the next person gets served, and the next one gets served, and the next one gets served, and so on until the queue's empty. So, an interface, queue, it'd be nice if I could join it. Kind of sad if I can't. It'd be nice if I could leave it. I might be curious to know how long the queue is. I might like to know if the queue is full or if it's empty. And there are all sorts of other things, but that was enough, and anyway I got to the bottom of the slide, so there's no space to add anything else. So that'll do for the time being. Notice, I'm not, none of these opening curly braces, closing curly braces, I'm not telling you how to implement the thing. It's just a wish list. This is what I want, this is what I want, this is what I want. Jump, 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 jump. And so the syntax is just follow this thing with a semicolon. It's a statement of intent. Everything in the interface will be assumed to be public. I can do other things with interfaces, but let's run this example first. Question so far? Everyone's comfortable what a queue is. So, a contract. That should make you think law. And that should make you think, how can I write a law that's a good law that will actually do what people want me to do? And will therefore also make you think of, given that somebody has written that law, how can I interpret what was written to my benefit? So the contract says, these are the methods. Thou shalt implement them. So I shall. Here is my first magic implementation of a queue. Public class Q1 implements, it's a statement of intent, queue. I have to implement every one of the methods I put there. So I've got the join, leave, get, length, is full, is empty. And for goodness sake, it's a class. I hope I can actually build some things. So I have a couple of constructors so I can build the stuff. And this is legally correct. Because I said the join method was of type void, so I didn't have to return something, it would just do things. Okay, I did something. Nothing. But I returned. The method join queue would receive the thread of control. It would pass it back to the main method. Everyone's happy. Compiler can't see any problem. That's good. Leave queue. There are many ways I could have done that. I do have to return a person. So I need some sort of person class. I could return null. But I thought I'd be at least reasonably nice. And I merely returned new person anonymous. I know the intent was to return the person who was at the front of the queue. But the compiler doesn't care. Why should it? It's not in its job description. All it has to do is return a person. And it did. Get the length. I decided to return integer.maxValue. Would have been amusing to return a negative number. Integer max value is just the biggest thing an integer could ever be, but try adding one to it and you'll have fun. So it's not the same as in mathematics. Boolean is full. I thought, well, I'll return true. It's got to return true or false. I've got to pick one of them. True's as good as either. Boolean is empty. I decided to return that to be true as well. It doesn't have to make sense. It just has to be legally correct. Then that fulfills my contract. And then I got a couple of constructors. This queue is so efficient it takes up almost no space, which is disarmingly true. It's also completely useless. And then I simply called the previous method with the value minus 47 because I never even used the integer in the first place up there. So it's stupid, but it does solve the legalistic statement. And those of you who've played at all with the graphical user interface stuff, whether it's AWT or Swing, if you actually looked at some of the implementations, you'd realize in many cases the implementations are open curly brace, close curly brace. Or open curly brace, return something stupid, and close curly brace on the assumption you might do something more useful when you actually do something nifty with it. So it's actually not unheard of to do this. But remember that's what you did, and that's the point of putting in comments. So maybe a slightly better implementation. Let's imagine an array. And so first person comes in, next person comes in, next one comes in, next one comes in. I keep some indicator of where the front of the array is, some indicator of where the back of the array is. I happen to choose the back to be a nice empty space so someone could go there. You can look at the details. There's nothing surprising in this. I'm just running through the process. You might be slightly concerned that, after 25 people have joined and 20 people have left, I've got this enormous space at the front of the array completely unused. And when all 25 people have left, I can't use it anymore. But suppose this was a queue for concert tickets or for food. Eventually you run out. So maybe you should have that kind of model. So it's not entirely unreasonable. Questions?
Why would you enter from the left, but the front is the left and the back is on the left?
And when I'm talking about, so the question is why would I enter from the left and I've got the front there and so forth? Well, I'm actually entering here, if you like, and leaving from there. But on the other hand, take a two-dimensional array, which is the rows and which is the columns for the computer. It doesn't matter. So this doesn't matter either. I could just as well have the front to the right and the back to the left, or I could draw the thing diagonally. So the question is reasonable, but I could actually have had it at either end. Doesn't matter. Other questions? So something which will allow slightly more reusability is the following. I didn't draw a pretty picture because I couldn't think how to draw the pretty picture in that particular system. But imagine that same array rolled around. So it is now a circular array. So I better not bend it. Imagine it. There's the front. There's the back. People join. People leave. People join. People leave. People join. People leave. People join. Okay, you get the gist. I can just keep on swinging around and around and around and around and around and around, continually using the stuff. I have a certain maximum amount of space available to do this, but I can keep adding and leaving right through that entire system. And this is where the joy, for those of you who did MATLAB, this is where the joy of Java starting its array counting at 0 really comes into play. Because the remainder on dividing by the length of this array will allow me to wind back to the beginning again. That's how I'm doing the arithmetic of it. You can look at the code, but you can see that one little change to the previous thing I did allows all this magic. Questions? Could I have arrays of different priorities if I wanted to have queues in that way? Absolutely. And we can certainly, you could build that yourself. We'll certainly talk about it for particular contexts. Then there might be a question of why would I be in one array versus another, and then you'd have various methods which might do some arbitration between which one you're entitled to be in. So absolutely. Imagine a traffic system where you wanted cars and buses and ambulances, and you wanted to give the right of the ambulance when they turned on their siren to be able to get to the front. Yeah, entirely natural. Other questions? Yes? No, that was a discussion. Okay. Somehow, intellectually, it's fine, and it's very nice, and it's got benefits, and we'll talk more about those benefits next time. What I want to draw one attention to is, philosophically, what is a queue? All I care about is there's a front where I join. Where I leave. There's a back where I join. And all I really need to know is when I get, you're the person, you got a nice big voice? Yeah. I heard it, that's good. So, you're the person serving at the front of this queue. And I'm here, and you finish serving. What do you normally hear people who are serving people at the queue say?
Next.
Louder.
Next.
All you want to know is, who's next? I'm finished with you. Fine, get out of there. I want the next person. And just in case they're hard of hearing, you could always ask me, oh, who's the next one? Oh, this is the next one. And we can be courteous about it because why not? So all I really need is something to house the people, together with information of who's going to be next, and just throw those pods, if you will, into the queue. Which gives me the following pretty picture, where essentially I have a node which contains a person and the next. So the person pops into the node, there's my person, and the node has a next which points to the next one. So all I need to know. I have a front which belongs to my queue. That tells me where the front is. I have a back. Fine. Tells me who's going to be going there. And I have my usual implementation. And the nice thing is this scales to take whatever space I need. It only runs out of space when the computer does. It doesn't have a mass of stuff sitting there. So if we do the obvious, and your name, sir? Dan. Dan, your point over there. Nice, good, solid pointing. Excellent. Yeah, great. So you're pointing over here. Your name, sir? Don. Don. Oh, that's good to be Dan, Don. We're getting good there. Can you point over there and be very rude? Thank you very much. It's a very lethargic pointing. Give it a bit more energy in it. That's okay, fine. Well, keep it there. I mean, he's doing his bit. So you just got pointed to. So could you maybe point over there? Great. You're pointing. Point over there somewhere. No, sorry. Your turn. Now point over there somewhere. Yeah, red. And you can point wherever you like. I don't mind. Somewhere. That's too subtle. Thank you. That's great. So here we have a queue. There's the front. I serve this person, and I merely say, Dan, who's your next?
Don.
Don. Okay. Notice I am now here, and Dan is still pointing in this direction, and that's marvelous for Dan. And you know what? Who's pointing to him? What's going to happen to Dan? Garbage collection. Sorry, Dan. Tompy? Don, who's your next? Okay, I go over there. My front is here. Oh, sorry, Don. You just got garbage collected. And then, so I proceed through, and I decide to add someone else. Would you please be so kind? Yes. No. Yeah. Yep. To be, no, in front. Exactly. Yes. You're the one. Could you be pointing to someone? Right. So you can see now that I've added someone else to the queue, and that's where the back of the queue is now. And I can serve this person and keep working through it. It all works dynamically. It's all very pretty. Go think about it and have a fun rest of the middle of the week. Cheers.